Okay, so imagine you're building software, right? And you're dealing with data.
Yeah.
But I mean, lots of data. Gigabytes, maybe more, like a huge log file or streaming video or maybe a massive database dump.
Right, the kind of stuff where loading it all into memory at once,
Hmm.
well, it's just not practical.
Exactly. It's often impossible. You hit memory limits, things grind to a halt. Maybe the whole application just, crashes.
It's a really common problem. Handling that large-scale data efficiently is fundamental.
And that's where Node.js streams come in, isn't it?
Precisely. Streams are Node's core answer to this.
Yeah.
They're designed specifically to let you process data piece by piece.
Little chunks instead of the whole massive thing.
Exactly. Small, manageable chunks. And that's incredibly powerful for efficiency, especially when you're doing I/O, reading files, network stuff, talking to databases. Saves a ton of memory.
So you don't need the whole file loaded before you can start working on it. You process it as it arrives.
You got it. And beyond just saving memory, which is huge, it fits perfectly with Node's whole non-blocking, event-driven model.
How so?
Well, because you're working in chunks, the Node event loop doesn't get blocked waiting for like a 10 GB file to load.
Mm.
It can handle other requests, stay responsive while it waits for the next little chunk of data.
Ah, okay. So it keeps the application feeling snappy. You also mentioned something about composability.
Yeah, that's another big plus. Streams are like building blocks.
Yeah.
You could easily connect different stream operations together to create these data processing pipelines.
Pipelines, right. So if I'm trying to get my head around this or maybe level up my node skills, what are the main kinds of streams I need to know?
Okay, there are basically four main types you'll run into. First up, readable streams.
Readable. Makes sense.
Yeah, they're sources of data. Data flows out of them. Think of reading a file with fs.creatorReadStream.
Or maybe like an incoming HTTP request, the data coming from the client.
Exactly. That request body is a readable stream.
Okay, so that's the source.
Right.
What about the destination?
That would be a writable stream. Pretty straightforward data flows into these.
Like writing to a file.
Yep, fs.createWriteStream is the classic example. Or sending an HTTP response back to the client. That's a writable stream too.
Got it. Source and destination, readable and writable. Any streams that do both?
Absolutely. Those are called duplex streams. They're both readable and writable. A good example is a TCP socket. You can read from it and write to it.
Okay, makes sense. And the fourth one?
The last one is the transform stream. Now, this is really interesting. It's technically a type of duplex stream, but its job is to, well, transform the data as it passes through.
So it reads data in, changes it somehow, and then pushes the changed data out.
Exactly. Think about compressing data with lib, Node's compression library, or encrypting data with crypto. Data goes in one way, comes out another.
That sounds incredibly useful. This is where that composability really shines, right? Connecting these different types. How do you actually connect them, make the data flow?
The most common and frankly most elegant way is using the .pipe method. You literally take a readable stream, your source, and you call .pipe on it, passing in the writable stream your destination.
So like source.pipe destination.
Yeah, that's it. Simple syntax. It's like plumbing, connecting a hose from the source tap to the destination bucket.
And I heard pipe does more than just connect them, right? It handles some tricky stuff automatically.
It does, and this is crucial. It handles back pressure.
Back pressure, what's that exactly?
Imagine your readable stream is like a fire hose, sending data really fast. But your writable stream is maybe slower, like a garden sprinkler trying to process it.
Okay, the sprinkler's going to get overwhelmed.
Right. Without back pressure handling, the fast source would flood the slow destination, probably using up a lot of memory, buffering the excess data. Pipe automatically detects this.
So what does it do?
It tells the readable stream, hey, slow down, pause for a bit.
Yeah.
Then once the writable stream catches up and is ready for more, pipe signals the readable stream to resume sending data.
Ah, so it manages the flow automatically. That's really smart, prevents memory blowups.
It's essential for stable, efficient pipelines.
Let's make this concrete. What about that classic example, copying a really big file without loading it all into memory?
Perfect example. So instead of read file, you'd use fs.createReadStream for your source file. Let's say source.txt.
Okay, so const read stream, fs.creatorReadStream, source.txt.
Yep. And then you create a writable stream for your destination file, maybe destination.txt.
So const write stream equal fs.createWriteStream destination.txt.
Got the source stream and the destination stream.
Now you just connect them with pipe.
Readstream.pipe.
write stream.
And that's literally it. Node will handle reading source.txt in chunks and writing those chunks directly to destination.txt. The whole file's content never sits entirely in your program's memory.
That really shows the power and the simplicity of it for that kind of task.
Definitely. Now, streams do emit events like data when a chunk arrives, or end when it's finished, or error if something goes wrong. You can listen for those if you need really fine-grained control.
But for just moving data from A to B or through a simple transform,
Pipe handles most of that complexity for you, especially the back pressure. It's usually the way to go.
so really understanding streams, and particularly pipe, seems like a fundamental skill for anyone serious about Node.js development.
Absolutely. It's how you build applications that can handle real-world data volumes efficiently. Whether it's large files, busy network servers, complex data transformations, streams are often the answer. It's a key step towards, becoming a really proficient Node developer.
Okay, so to recap, Node.js streams let you handle data chunk by chunk, vital for big data and I/O efficiency. And pipe is that elegant method for connecting streams, building data pipelines, and it automatically manages things like back pressure for you.
That nails it down pretty well. It's a cornerstone technique.
So if just piping a file copy is the basic use case, it makes you wonder, doesn't it? What kinds of really complex, powerful data flows could you build? Imagine chaining multiple transform streams together. Maybe unzip, parse filter, rezip, all in one go, super efficiently.
Yeah. Exactly. The possibilities for building sophisticated processing pipelines are pretty vast once you grasp the core concepts. That's something for you, the listener, to think about.